Good morning YouTube. Today I thought we could cover how to set up a project in Cura 4.8 and some of the things to look for when printing in PETG. I'm currently working on an R2D2 using Michael Badley's files, so huge shout out to him. Today I'm slicing one of the ankle sections, so let's get into it. First thing you're going to need to do is find your files. Today I won't be covering how to cut STL or OBJ files because the files from Michael Badley are already pre-cut. I'm currently working on the ankle. I've already printed the ankle back and the curve, so the next one I need to print is the hinge. My plan is to print what is called a 232 droid, where R2 can pivot, and when he pivots the middle leg will drop out of his chassis, and then it can also be retracted and he will stand back up vertical again. It's not something I'm going to fit initially. It's basically I'm just printing the long ones to future proof myself. So I've loaded the file, as you can see, in Cura. One of the great things about these files is they need virtually no supports, and a lot of the time they're loading in the correct orientation. I do have supports turned on by default, and they'll generate anywhere where there's a 50-degree overhang or more. So in this situation there will be some supports in these bottom holes here. In this case this is a fairly straightforward piece. So I'm printing with PETG, and PETG is notoriously bad for stringing. So I thought this might help with some people who are having trouble with PETG. I'm printing this on a Tronxy with an 800mm Bowden tube, and I get very minimal stringing, so I'm very happy with that. My CR10 that has a significantly shorter Bowden tube gets almost no stringing at all. The Tronxy, partly because of the length of the Bowden tube, partly because I haven't got the acceleration tuned in exactly where I want it yet, gets a little bit more stringing. Because this is a functional part, I'm printing it at 0.24. For high detail visual parts I normally print at 0.12. As this is functional, I will print it at 0.24 to make the print a little bit quicker. Again, because this is a structural part, I'm printing it at a wall count of 8. R2 is quite heavy. I think they end up around about 50-60 kilos. Also, to give me the ability to sand it and still leave some walls there after sanding, I'm running a reasonably high wall count of 8. I personally use concentric. You can use lines, you can use zigzag. I do a lot of functional printing, like car parts and armor pieces, and I find that by sticking with concentric, one, it helps minimize the stringing, because as it finishes a layer it's almost like vase mode. It continues, it just works its way in, and I also think that gives you a really good structural integrity, because you don't have that break point because your layers are all lined up. Particularly when making car parts, I use concentric a lot, just because I feel like it gives you more flexibility on which angle to print, because it gives the print more strength. Wall optimization is just good. It helps reduce the number of retractions, less stringing. Some people don't use this, but I use fill gaps between walls. I'm a great believer in, again, it adds a marginal amount of tensile strength. Z-seam alignment, I always use sharpest corner. I think it makes it the easiest to hide. So you put it on the sharpest corner, and then when it comes time, if you do have any issues, you can just hit it with a piece of sandpaper and clean it up. Smart hiding, again, like, to me, it's all about getting a better finish. So even though I'm printing a functional part, I still am trying to get as good a finish as I can. On my CR10 I leave ironing on all the time. I don't iron at all on the Tronxy. The Tronxy gets a really nice finish without me needing to iron. And also The Tronxy I predominantly use for functional parts. Because this is a load bearing part, I've got 50% infill. Most of my prints I normally do around about 20. But in this case, because this is the ankle joint of R2, based on the recommendations from the Droid building forums, I'm running 50% infill. That's also the infill I use for most of my car parts. It gives them really good tensile strength. I used to use cubic and quartet cubic a fair bit in my printing, but I've recently switched to triangles because it uses it gives a slightly neater print, and I was particularly on the Tronxy, not so much on the CR10. I was getting some reasonable amount of internal stringing, probably because of the length of the boner tube. Printing temperature is something you kind of need to tune in yourself. It will vary from machine to machine. I use the same filament in both of my machines, and in one I have to run it at 245, and in this one I run it at 230. Also, it can just, even things like colour. If I'm printing grey or black, I'll run 235. If I'm printing white, I run 230, sometimes even 225. The white, I think it's something to do with the process of how they make it white. String, at least the brand I use, strings a lot more than the other colours. So I always lower the temperature just a little bit. I run really low speeds. A lot of people, you see a lot of YouTube videos where people are like, I can print this at 100, I can print this at 60. I run really low speeds. I'd rather print it at 30 and let it sit there for 3 days and do its thing and work every time. I used to try and print most stuff at 50 or 60 depending on the printer, and particularly on really tall prints on the CR10, supports would fall over 250mm in the air, and you're printing something that's only like 25 by 25 on a moving bed. It's just not practical. You'll get, the part starts to wobble and you get layer shift at those high Z heights. So it's just not practical. My printer's in another room, so I have to check it via webcam or go out there to check it. So I'd rather print it a little bit slower and know that it's going to work. I've also found that at these speeds I get some really good bridges. I did a print a few months ago on my CR10. There was a internal bridge that I forgot to delete. The bridge ended up about yay long, so about 150 long. It was the insides of a helmet that we were prototyping for an Ahsoka headpiece. Because of the settings that I use, it bridged. And that's a big bridge for it to cover. It depends what you're using it for, but I stick with the lower speeds. My travel settings are pretty much standard. Retraction I think should always be on, as with retraction at layer change. My retraction distances are very high. This is partly because I have a 800mm boner tube. I run a micro Swiss hot end, so these figures are particularly high for a micro Swiss hot end. I personally have found this to be really good for support stability. It means it strings a bit on the supports sometimes. And again, avoid supports when travelling, avoid printed parts when travelling, retract before outer wall, all prevent your print from being knocked over, particularly if it's a tall print. A lot of people recommend running lower fan speeds for PETG. I've seen websites that recommend anywhere from 50%, 60%, some even recommend not running it at all. I run twin 5015 fans at 100% on a PET's fang. I think that's one of the reasons that I get minimal stringing, because they're very effective at cooling it. A lot of the websites say that if you run your fans too high, it gives you less tensile strength, and definitely I have found that when these speeds are higher, it can sometimes have issues adhering. And the speeds I've run it, I've never had any issues. Supports are going to vary depending on your system, and also whether you think the print needs supports or not. These are my generic support settings, which I mostly leave as is all the time. I'm a big fan of tree supports. Again, I use a skirt and a reasonably wide skirt, particularly with a long Bowden tube. It gives the printer a chance to get any blobs off the nozzle from leveling and just get the pressure in the Bowden tube to be the correct pressure. The only other thing I would probably highlight is that if you want to do a lot of bridging, the experimental bridge settings, which can be turned on in Configure Cura. So if you go into Configure Cura and go to settings, you can turn setting visibility on and off, and down in the experimental section of Cura, enabling the bridging setting, enabling the tick box that, here we go, enabling that tick box, and those two there are really helpful, because what it allows you to do is set an angle that if the overhanging wall angle is greater than that, it'll lower the speed of the print, which gives you better adherence on your overhangs and means your overhangs will work better. I get really good overhangs out to about 65-70 degrees without supports. It's just a single tick box, but I find it makes all the difference. So once you've got your settings how you like it, it's just a matter of slicing it. So as you can see here, I've got a fairly thick skirt, and given the orientation, there isn't going to be that many supports. It has put supports in under those ones there. It hasn't done supports in the little ones, which is what I was expecting. You'll notice that it's very dense. That's because I've got the infill particularly high. Here at layer 1 you can see the supports. I could probably turn them off, particularly the way they're closing out, and I think in this instance I will. These outer walls are going to be really solid, really good for tensile strength. I normally save it locally and then to the SD card so that I have a backup just in case something happens to the SD card. I also always save the project, because say you have a print fail because of a setting where you're like, oh, that ended up weaker than I wanted. It just saves you time because you don't have to re-import it all. And now you're ready to upload it to your printer. So yeah, I hope you have found this helpful, and if you did, please like and subscribe.